Hi everyone, this is 1.7 compositions of functions. So to start for the first example, we're going to find the domain of different functions. So remember, when we're finding the domain, we're finding the set of x values that work for the function. So we want to make sure that we take out any x values that make our function undefined. So the first one here is we have f of x equals x squared minus 7x. Now, x squared minus 7x is a parabola, so we know that parabolas include all real numbers. So the domain of this function is going to be negative infinity to positive infinity because it's going to include all real values. For every number that you plug in for x, you'll get a real number y, so it's going to be all real numbers for the first one. Now, for number 2, it's going to be a little bit different. We have g of x equals 3x plus 2 over x squared minus 2x minus 3. Now, we know that division by 0 is undefined, so we need to exclude all x values that make the denominator 0, because we can't have our function or any numbers in our domain that make the function undefined. So the first thing we're going to do is we're going to take the denominator, x squared minus 2x minus 3, and we're going to set it equal to 0, because we want to find all those x values that make the denominator 0 and take them out. So we are going to factor this expression, or this function rather. So I know that I need a 3 and a 1 here because these two numbers have to multiply to the c term here. And they need to add to the middle, which is negative 2x. So when we factor, we should have x plus 1 and x minus 3. Then we're going to take each factor, set it equal to 0. So this we're going to subtract 1. X equals negative 1. Over here, plus 3. And we're going to get x equals 3. So those are the two numbers that we need to exclude. We need to exclude negative 1 and negative 3. So we exclude x equals negative 1 and 3. And how we're going to write this is our domain is going to go from negative infinity all the way to negative 1, union, negative 1 to 3, and then 3 to infinity. Just make a little wall here. So we write our domain like this because this is containing negative infinity to negative 1 and negative 1 to 3 and 3 to infinity. So those numbers negative 1, which are here and here, and 3 here and here are not actually in our set. So that is how you find the domain. For number 3, we have the square root of 3x plus 12. Now remember, non-negative numbers have real square roots. So we have to make sure the number under the square root is positive because we can't take the square root of a negative number. So the way we do that is we do 3x plus 12. And since we don't want any negatives, we're going to make it greater than or equal to 0. And now we're going to solve the inequality. So subtract 12. 3x is greater than or equal to negative 12. Divide by 3. And x is going to be greater than or equal to negative 4. Or we can write it as negative 4 to infinity. And there should be a bracket there. Negative 4 to infinity. And that is our domain. So again, we can't have a negative under the square root. So we set what's under the square root greater than or equal to 0, and then we solve. And there's our domain. So I'm going to pause. Everyone should pause this video, and I want you to try 4, 5, and 6. All right, so here is what we got for 4, 5, and 6. So for 4, it is a parabola again, so the domain is all real numbers. For 5, we set the denominator equal to 0 because we want to get all the numbers that make the denominator 0 out of the domain, because if the denominator is 0 of a fraction, the function becomes undefined. So that's 7 and negative 7. And for 6, since the expression is under a square root, we want to make sure there are no negative numbers. We want to get rid of all the x values that make this under here negative. So we set 9x minus 27 greater than or equal to 0, and we solve. And we exclude all numbers that are not greater than or equal to 3. All right, next we're going to combine functions. So we have let f of x equals 2x minus 1 and g of x equals x squared plus x minus 2. So we're going to do each question and then determine the domain. So the first one we're going to do is we're going to add the functions together. So we're going to do f plus g of x, which really is just f of x plus g of x. So we're going to add the functions together. I know my hand gets in the way. I'm trying to move it so everyone can see. So we have 2x minus 1 plus x squared plus x minus 2. Now this just becomes straight algebra. 2x minus 1 plus x squared plus x minus 2. When we combine like terms, we should get x squared plus 3x minus 3. And that is combining them, that is f plus g of x. Now we also need to determine the domain. So since it is a parabola, our domain is all real numbers. So I just added the two together. In B, f minus g, same type thing. We're now just going to subtract them. So we're going to do 2x minus 1 minus x squared plus x minus 2. 2x minus 1. Now we're going to distribute this negative. Minus x squared minus x. And that is going to become a plus 2. Now I'm going to combine like terms again. So I have negative x squared plus x. And then we are going to have plus 1. And our domain, again, all real numbers. So again, all I'm doing is adding and subtracting the expressions together. If I'm going too fast at any point in this video, feel free to just pause. For C, we have f times g of x, so we're going to multiply the two together. So we're going to be doing a lot of distributing. 2x times x squared is 2x cubed. 2x times x is 2x squared. 2x times negative 2 is negative 4x minus x squared minus x plus 2. So that was just distributing. And now I'm going to simplify. So I should have 2x cubed plus x squared minus 5x plus 2. And now this is a cubic function, but the domain is still all real numbers. Again, this is a cubic because I have the 2x cubed, but the domain is still all real numbers. So I just multiplied them together. And last, we have f over g. So I'm going to take f, 2x minus 1 over x squared plus x minus 2. Now this can't be simplified anymore, so it's good the way it is. All we have to do now is the domain part. Now you should remember from example 1, since we have division here, 2x minus 1 divided by x squared plus x minus 2, we can't have any x values in our domain that make the denominator 0, so we're going to take x squared plus x minus 2, set it equal to 0 so that we can exclude all those x values that make the denominator 0. So again, we're going to factor x 2, 1. We should have x plus 2 and x minus 1. So that is x minus 1 equals 0, x plus 2 equals 0. We're setting each factor equal to 0. Then I'm going to get x equals 1 and x equals negative 2. So those are the numbers that we need to exclude. So our final domain is negative infinity. I'm going to try to squeeze it in here. Negative infinity to -2, -2 to 1, and 1 to infinity. Okay, so that is combining functions. So what I want everybody to do is we are going to go to right here. I want everybody to pause the video and do A, B, C, and D right now. Same type thing. Here's what you should have got for 2, A, B, C, and D. The first one we added, the second one we subtracted, third one multiplied, fourth one division, and we have all the domains to the side. So pause the video and check your work to make sure that your solutions are correct. All right, next we're going to add functions and determine their domain. So the first thing we're going to do is just add f of g. And we get lucky with these radicals because all we really have is the square root of x plus 3 plus the square root of x plus 2, and we can't simplify that anymore. So next, we have to find the domain of f plus g. Now, when we talk about finding the domain of f plus g, we need to find numbers that are common to the domains of both. So first, I think we should find the domain of both f of x and g of x. So I'm going to do that on the side here. Because again, we want to find the domain of, we want to find numbers that are common to both domains. So we're going to go over here, we're going to do f of x equals the square root of x plus 3, and g of x equals the square root of x plus 2. So again, to find the domains, we're going to do x plus 3 greater than or equal to 0. So x is going to be greater than or equal to negative, I didn't mean to write 0. Greater than or equal to -3. So the domain is -3 to infinity. And over here, x plus 2 greater than or equal to 0. X greater than or equal to -2. Your domain is -2 to 0. -2 to infinity. So now when we talk about the domain of f plus g, we have to find numbers that are common to both. So when we think of the numbers that are common to both domains, if I were to draw a number line for this one, it would be all there from -3 all the way to infinity. Now, for a domain of g of x, so this is f of x. For g of x, it would be here. So the numbers that are included in both are from -2 to infinity, because f of x has numbers in its domain that g of x does not have. So the domain of both is just -2 to infinity, because that's where the numbers start being in common, right here. Because now they have all those numbers in common. G of x has numbers, doesn't have numbers that f of x does, so we can't say that it's -3 to infinity. So at this point, pause the video and do number 2, C, and D. All right, and here is what we got for 2, C, and D. So at this point, pause the video and check your work, and we will go on to example 4. All right, we're going to start example 4, composite functions. So we're going to start doing f of g of x and g of f of x. So I'm going to come over here to the side just for a little, because there's a few ways we can write this. You might see f of g of x, or it written like this. Those mean the same thing. It means that you're plugging g into f. G is on the inside here, so again, that is going g into f. You also might see this, g of f of x, which is the same as it written this way, where you will have f going into g. So again, there's a couple different ways you can see it, but you got to know what to plug in where. So the top one is g into f, f of g of x. The bottom one is f into g, g of f of x. So for number 1 here, we're doing f of g of x, which is equal to writing it this way, f of g of x. So here's what we're going to do. I'm going to say f of x is equal to 3x minus 4. Now I'm going to put g of x in for x. So f of g of x. And now everywhere there's an x in f of x, I'm going to plug in the function g. So see where my pencil is, right where this x is? I'm going to plug the entire function g of x in for there. So 3 times x squared minus 2x plus 6 minus 4. So again, just take a look. I'm just going to get a colored pen out here. For this x, I put in the function g of x. Just like over here, for this x, I put in the function g of x. And now I just distribute. So I'm going to work out a little bit. So 3 times x squared is 3x squared. 3 times negative 2x is minus 6x. 3 times plus 6 is plus 18. And then the minus the 4. I simplify and I get 3x squared minus 6x plus 14. And that is how you do f of g of x. So again, I replaced x with g of x for every x in the function f. All right, next we're going to go down to number 3 here. 3 is a little different because we have f of g of 3. So there's a couple things we want to do. So you could actually do it one of 2 ways. First, let's do f of g of x, and let's plug that in. So we're going to write f, and now instead of putting this x, I'm going to plug in the function g of x. So 4x squared minus 2, and then minus 3. Now I can plug in that 3 into the x's in g. 2 times 4 times 3 squared minus 2 minus 3. So that's 2 times 4 times 9 minus 2 minus 3, which is 4 times 9 is 36. You know what? Let me write under here. 2 times 36 minus 2 minus 3, which is 2 times 34 minus 3, which is 65. Or what you could do is you could find g of 3 first. 4 times 3 squared minus 2, and say, oh, that's 34, and then plug that number in for f, because that would be f of g of 3, which would be 3 times, 2 times 34 minus 3, which is still 65. So we're still plugging the values in for x in the order that we're supposed to, right? F of g of x. So g of x went into f of x, and then we did that of 3. So either way works. So what I want everybody to do now is pause the video and do 2 and 4. I want everybody to do 2 and 4. All right, so here's what I got for 2 and 4. So if we look at 2 for a second, this actually requires us to do a little bit of work, only because now we're plugging the function f into every x in g. So right here and right here, where I just circled, you have to plug in the function f of x. So 2 times f of x squared minus f of x minus 1. So we have to do a little distributing and a little bit of algebra, but you can check out all the work, and it comes out to what I have circled. For number 4, again, we're going to evaluate f of 2 and then plug that into g. I did g of f of x, got a function for g of f of x, and then plugged in 2, but either way you should get the same answer, and I got in 23. The last thing we're going to do here is decomposing functions. So basically going backwards. So we want to write h of x as a composition of two functions. So our two functions, we're going to write f of x, g of x. So f of x, if we think, could be what's happening to the 3x squared minus 2x plus 1. What was it really? It might have been x to the 5th. And g of x could have been 3x squared minus 2x plus 1. So that means h of x could have really been what? It could have been plugging g into f of g of x. Because if you think about it, you plugged in g of x into f of x. Same thing down here at the bottom, right? There's f of x. You could have had g and h. So g of x could have been the cube root of x, while h of x could have been x squared plus 1, right? We're decomposing, we're working backwards. So f of x could have equaled plugging h into g. So g of h of x. Oops. And there you go. Those are all the notes for 1.7.